Hi, Assalamualaikum. I am Nur Najwa. Today we will be learning about communication in distributed system. The objective to learn communication in distributed system is first, to identify different layers of communication from protocols to application programming interface APIs. Second, to present the various ways and widely used models of communication in distributed system. Third, to specify different paradigma of communication. And fourth, to be able to program applications with distributed object and internet protocol. Next, we will talk about the protocols. First, we talk about layered protocols. Layered protocols is an open system interconnection that has been developed by the International Organization for Standardization (ISO). The framework to discuss the layers and functionalities of communication protocols are shown in the screen. These pictures show the face of the protocol. And this picture shows a typical message as it appears on the network. Next model is OSI protocol layers. OSI means Open System Interconnection. There are 7 OSI protocol layers. First, physical layer. It deals with the transmission of bits. Second, data link layers. It deals with detecting and correcting bit transmission errors. Third, network layer. It performs multi-hop routing across multiple networks and implemented in any system and routers. Fourth, transport layer. It is a reliable delivery of data. Session layer. It provides dialog control to keep track of which party is talking, and it provides synchronization facilities. Next is presentation layer. It deals with non-uniform data representation and with compression and encryption. And last, the application layer. It is support for user application like HTTP, SMPT, and FTP. We move to models of communication in distributed system. First model is remote procedural call, RPC. RPC is a request made by a process in one computer to another computer across a network. RPCs tend to operate in real time because the calling program usually waits until it receives a response from the call program. In this respect, RPCs are synchronized. RPCs also are required in applications in which a procedure should not continue until it receives the information it needs from the remote system. Next model is Remote Method Invocation (RMI). RMI is the basis of distributed object computing in the Java environment. RMI defines how Java components can interoperate in a multiple Java VM environment. RMI provides the tools that programs need to create distributed Java application objects that can invoke methods on other Java applications that are running on other virtual machines, such as remote hosts across the internet. Invoking a method is like asking another program to do something.
Now we move to message-oriented communication. In this introduction, it shows we will move into message-oriented communication if we assume that there are no responses from RPC or RMI. Persistence and synchronicity in communication. The figure shows the general communication system connected through a network. As you can see, Each host is connected to a single communication server, which are a receiving host and sending host. They are connected to a single communication server. Host and communication server can have buffers. The figure A shows a persistent and synchronous communication which is sender continues after submission, while the figure B shows persistent synchronous communication which is sender is blocked until message is stored at receiver host, message is received and response is received. The figure C shows transient asynchronous communication, while the figure D shows receipt-based transient synchronous communication. This is the figure of other transient synchronous communication. Figure E, delivery-based transient synchronous communication at message delivery, while the figure F shows response-based transient synchronous communication. We move to the topology of communication. Client-server communication. There are three qualities of service, which are request protocol, R, request reply protocol, RR, request reply acknowledgement protocol, RRA. Quality of service client-server. Exactly one, the service is executed only once, at most one. The service request may or may not be or have been executed. If not, the client is being informed of the failure at least once. The call may be once or more than one time. Maybe it is neither guaranteed that the service has been executed, nor is the client informed of failure occurrences should there be any. Request protocol. This protocol is unsuitable if the service has to return data or the client has to know what happened to the service execution. The advantages are there is only one message involved and the client can continue execution as soon as acknowledgement of message delivery has been returned. Request reply protocol is to be applied if client expects result from server. As you can see in the figure, the client requests service execution from server to request message, and then the server will deliver a service result in reply message. If the reply message is not received after a certain period of time, this can have many reasons. Either the server has not finished the execution yet or the reply message has been lost. Request Reply Acknowledgement Protocol (RRA). The RRA protocol is designed to limit overhead of the maintenance of a history on the amount of client-server communication cycle. An additional acknowledgement message is being added by RRA to RR, which is sent by the client as soon as a reply has been received, as you can see in the figure. Point-to-point communication. This point-to-point communication is always involved exactly two processes. There are several variations on how the sending of a message can interact with the program. Synchronous. Asynchronous communication does not complete until the message has been received. For example, a fax or registered mail. Next, asynchronous. An asynchronous communication completes as soon as the message is on the way. For example, a postcard or email. Blocking and unblocking. Blocking operation only return when the operation has been completed, while non-blocking operations will return right away and allow the program to do other work, for example, receiving a fax. Group communication. Client-server request. The communication of the client-server pattern was bilateral, since there were only two parties involved, which are client and server. Moreover, it was intimate, as the client component always had to identify the server component. Sometimes other properties are required. Communication between multiple components and anonymous communication. The concept of broadcast and multicast. Broadcast is send message to a group, while multicast is send message to subgroup only.